What is up, everyone? Welcome to my channel. I am Andrew, also known as Waterproof Jedi in various internet circles. Today's video is about control rig, more specifically building a control rig that will allow you to do some really cool stuff with your game animations at runtime. What we'll do in this video is we'll start in Blender, build an armature with a bone structure. We will orient those bones in a way that works best with control rig. We'll talk about how to export that and some settings that make life a lot easier. We'll talk about importing it into Unreal, and then from that point on, we'll build a control rig step by step. And at the end of it all, we're gonna have something really, really awesome. So I'm very excited to get started with you, but first, I want to point out that these are just my personal workflows and techniques, and I'm not trying to suggest that this is the correct or the only way to do this type of work. It's simply what has worked best for me, and has the added bonus of being able to be called shippable, because this is the technique and workflow that I use to create all of the underwater creatures in Voyages of Nera. The tools in Unreal continue to evolve with each engine release, and keeping up can be nearly impossible, but Epic has done an incredible job creating extensive documentation on control rig and has provided incredible examples that I highly recommend grabbing and diving into to learn from. I'm still and always will be a student at the end of the day, and there's still so much to learn on the subject of control rig, but I want to say that control rig is built on the core concepts of traditional rigging and is not necessarily a replacement or a substitute. So I really recommend understanding the fundamentals of both character, mechanical, all kinds of rigging before you start with control rig. Having a strong grasp of those core concepts is really just going to make your life easier. It's going to make learning control rig more fun, and it's just going to make you a better tech artist at the end of the day. So I'll link some of my favorite rigging resources below if this is your first step on your rigging journey, and hopefully they're super helpful for you. With all that said, I am excited to get started. I hope that this is informative. I hope that it's fun, and I hope that it's super dope for your project and that everything goes amazingly from here on out. So let's get rolling. Okay, so first things first, in Blender, I create a basic skeleton. I don't want to get too deep into the process of creating an armature and skinning the mesh in this video, but the basic concept is the same here as in any traditional character rigging situation. Ideally, there is a design for the character's behavior. Maybe the way it attacks or moves have something unique about it that you need to consider when building your skeleton and the rig. In this case, the goal was to create believable movement for underwater creatures. And for the most part, swimming creatures begin their movement starting with their head, and that movement propagates down the spine. So what we need to do here is make sure the root of the movement is placed at the neck between the spine and the head. The reason for this, and say not the nose or something, is because we still want to be able to control the head separate from the body. And that'll make more sense once we get into control rig. But if you've watched sharks on like Shark Week or something, you'll notice that if they change directions very quickly, they move their head slightly before the body reacts. This is typically true for pretty much all swimming creatures, at least that I've seen. So on the animation side, being able to control the head separate from the body gives us some flexibility and the overall ability to add some extra detail into the movement. Now, one of the most important things to be aware of when working between control rig and Blender is that Unreal expects the bone's primary axis to be the x-axis and its secondary axis, or the up axis, to be the y-axis. My best guess as to why is probably to avoid gimbal lock within the engine, but that's just a guess. I'm not 100% sure about that. This was easily the biggest struggle I faced when I first started working with control rig and custom skeletons. This is probably not an absolute rule, and I'm sure there are ways to work within control rig with different bone orientations, but I'm not trying to break Unreal Engine. I just want to make a cool shark here. So these are the settings that have worked best for me, and I recommend you give them a shot, and hopefully if you've run into some of the same issues, this resolves that for you as well. Okay, here we are in UE5. One step closer to the greatest shark rig that could ever be imagined. Keep in mind, I'm in 5.6, so some node names as we get further in this may shift a little bit, but I'll try and point that out in comments. One thing we need to do before we dive in is make sure that control rig is enabled in your project plugins. I believe in 5.0 it comes standard, but you might want to just double check just to be sure. Next, and maybe the most vital step here, is getting the dang skeleton into the engine so that we can start building with it. So all we have to do is import, no special settings, just flat out regular importing. All right, nice. So we have our skeletal mesh. And what I like to do is double check that the hierarchy looks as expected and that our bone orientations are correct. You'll notice here the x-axis is pointing down the length of the spine and the y-axis is up and down. And again, if you look through all of the control rig content that Unreal has provided, you'll notice that this is the bone orientation that they use in pretty much all of their rigs. Now, by default, Blender generates a bone at the top of the hierarchy and uses the name of the armature as the bone name. So if your armature is named armature, then your root bone will also be named armature. This may be obvious to a lot of you, but bone names have a little extra importance in Control Rig once you get into sharing rigs across different characters and skeletons. If you keep your bone names as similar as you can between characters that have similar anatomy, then the easier and more smooth the process of applying a rig to another character will be. Very simple, but equally important. Once we're sure that the mesh has bones and in the right order, we can start getting into the juicy part of this video. I like to start by making an anim blueprint first because that's ultimately where all of this cool content will live and will be the bridge between the animation side of the character and the behavior and logic side of the character. So first we'll add a state machine and just hook that up to the output pose. Once we've done that, we can open up the state machine and add an idle or swim state in there. This is ultimately where we will place any swimming, idle, or other locomotion animations to make sure it's affected by the control rig. And I want to point out that using control rig in the way we are does have the side effect of needing to put more of the animations in the actual anim blueprint. What I mean by that is typically enemies and players have the basic locomotion animations and their transition logic all in the anim blueprint. But a vast majority of the time attacks and ability animations are played via a montage, either in the character blueprint or maybe a gameplay ability. But the problem there is that montages override the character anim blueprint, which means the control rig is also overridden, and so will the effect the control rig has on the character skeleton. This would lead the smooth locomotion and traversal animations being affected by the control rig to abruptly snap or pop to an attack or ability animation, which is pretty distracting and really kills the vibe. So you'll really want to think about what info you need from the ability or blueprint so that you can reference it in the anim blueprint to drive the transitions to and from those animations. This makes sure control rig stays downriver and all animations are being affected by it. In the case of the stalker here, because he's able to swim and attack, we need to make sure that the transition from swimming to attacking is seamless. And that required us to build his attack into the anim blueprint so that the control rig was downstream. Now, keep in mind that this isn't a requirement or a limitation of this setup, because in the case of the crab, I was able to actually take advantage of the fact that animation blueprints are overridden by montages and keep its anim blueprint super simple and just stick to the procedural control rig logic. And because crabs have a bunch of legs and they're all connected to the ground, I didn't really have to do anything other than play the attacks when the time came. And even if the attack had, say, a running start or something, root motion from the montage would take care of that, and any leg movement in the animation would look the way the animator intended. Then from in that montage, the anim blueprint would smoothly blend back in based on your blend in and blend out settings. So all in all, think about the signal flow or data flow of each character. Where does it start, where does it end, and where does control rig need to be for you to get the effect you're looking for when your character is doing whatever you're trying to get it to do? Okay, and here we are. The time has come to build this dang control rig. All you have to do is right-click and create a control rig. You can also right-click the skeletal mesh and generate a control rig from the bones in the mesh, but there are some pluses to getting a blank control rig that I'll get into here in a second. So let's open that up, and you'll notice off the bat a node called forward solve. This is the first of 3 core elements in control rig that enables us to build our rig logic. And ultimately, this is actually very accurately named because it sends data and logic forward to bones and controls. And in addition to the forward solve, there's a backward solve, which, you guessed it, does exactly the opposite of forward solve and allows you to apply bone transformations back onto their controls in the rig, letting us edit baked animations. It's pretty awesome. The third and last vital piece of control rig is the construction event, which pretty much acts the same as construction script in a blueprint. so we can create complex rig construction logic without it bogging down the rig at runtime. Basically, this is where the house is built, and the forward and backward solves are what we do in that house after it's built, if that makes sense. So here is where we can create our controls, create nulls, establish parent relationships, even affect initial transforms, put things where they need to be, so that we can build a rig procedurally. So let's first get our skeleton into our new rig. This is where creating a blank rig can be kind of handy. If we create an import skeleton node, we are telling the rig to always import the skeleton when the rig is loaded. This is great if you are iterating on the overall skeletal structure or have to make changes as you're building the rig, because this will update the hierarchy automatically. And in control rig, there's 100 ways to do anything. You could also manually update the skeleton each time you make a change right here. But this import skeleton node is super great because this will automatically update the bone hierarchy from whatever mesh we have assigned to the rig. Okay, so now we have our skeleton, and the first step here is to start creating controls. You can manually create controls right in the rig hierarchy. You can reorder them, adjust their shapes, sizes, colors, and transforms, all from right there, which is great, but we can do better. Let's create a function that will generate our controls for us based on the bones and their positions. Since this rig is just forward kinematic, we can call this something like create FK control chain. Now that opens up our new function where we can find our entry and return nodes. If this looks suspiciously similar to blueprint functions, it's because it's identical to blueprint functions. And in fact, control rig is really just building a rig in blueprint for the most part, because you'll find a lot of the same nodes, functions, and info you can use to build your rigs as you would in blueprint. So what we want to do is get all of our bones in the skeleton. To do that, we'll need to create a variable that will allow us to store references to our bones. This is where you'll be introduced to the data you'll likely use the most in control rig, which is the rig element key. This is basically a data type that allows you to store exactly that, rig elements. For each of those bones, let's have control rig generate a control that makes the corresponding bone its parent. So here we grab a for each loop, and from that, grab a spawn control node. Now let's have the bone or the element here be the parent of the spawn control. Let's also use the bone name to generate the control's name. To do that, we can pull off the name pin and use the concatenate node to add underscore control to the end of the bone name. This is a great example of why naming our bones in an intuitive way early on is pretty important. Controls can basically be whatever you want based on whatever you need them to do. So if you need to only rotate or translate, you can assign that to the control here. But in this case, we want to make sure we can have the control do whatever we want. So let's make it a transform control. At this point, I prefer to just get all the controls generated first and then move them around after that, rather than doing it all at once. So what we'll do is create a new local variable array of rig elements called our controls. Let's drag in a reference to this new variable, give ourselves a little room to work. And let's set our number of elements in the our controls array with this set at node to the number of bones in the chain with this number node. Obviously, I can't not organize my graph. I'd hate for you to know just how messy I can be. Then we'll need to update the control array to make sure we're keeping track of the controls that have been created. So we get each control and assign that as the element being set for each index in the bone array, and obviously more organization. Now that we have all of our controls created, we can go ahead and position them where their corresponding bone position is in the skeleton. So off the completed pin, let's grab a set transform array node. Grab a reference to our controls and reference to our bones, and make our controls the item we will be setting the transforms of. And as you've probably guessed, we will reference the transforms of the bones and use that as the new transform for each of our controls. The last step here is to make sure this set transform array node is setting the control's initial position and not its current position. This is basically setting the control's reference pose or base pose. Okay, awesome. Let's compile and save. And now all we need to do is drag our function into the graph and tell it what bones we want to make controls for. We can do that a couple of ways, but the way I find easiest is to just pull them straight in from the hierarchy like this and create an item array. Hook that into the bones array and boom. You notice down in the hierarchy here, we have controls. You may not see them at first, and it's likely because they are super small, so we'll need to mess with the shape a bit in our function. We open the function back up, give ourselves a little bit more room here. We can go up to our spawn control node and open up our settings and go to the shape options. Here's where we can set all kinds of parameters for our controls, but let's start with the scale so we can see what we're working with. Now let's set a better shape like a circle, and let's rotate these guys 90 degrees on the y-axis so they follow the direction of the shark's body. Now you probably have noticed that since we are generating all these controls from this one node, when we change these values, it affects all of the controls uniformly, which isn't really ideal and makes the rig look a bit clunky. So what we can do is add a new input variable, call it something like control shapes, and then we'll need to set the variable type to the, and brace yourself for this one, rig unit hierarchy add control shape settings node. Easy. Now if you open this input variable up, you'll see it has all of the same elements as the spawn transform control node. This is what we use to control the shape parameter values per instance of the function in our rig. Let's go back over to our spawn control node and get a reference to our new variable and plug in the corresponding pins. Let's go out to the main graph, and now if we play around with these values, you can see them actually affect our controls. It's pretty cool. Now we can control our control shapes anytime we generate a control with this node. So arm, leg, spine, finger chains could all have their own sizes, shapes, and colors. But we still have the issue that each control is the same size, and it's again, clunky. So what I'd like to do is have the controls follow the shape of the shark a bit better. Let's jump back into the controls function and see if we can add a taper down the length of the bone chain. First, we can create two float variables, one for the control chain start scale and one for the control chain end scale. Cool. Now, if we go back to our for each loop node, we will find a pin called ratio. And what this does is it generates a 0 to 1 value range starting from the first bone in the chain to the last bone in the chain. Dear God, it's perfect. With this, we can distribute scale values down the chain to our generated controls. All we need to do is map this 0 to 1 ratio to the proper bones. So let's get references to our new float variables. Let's also fix the name of this variable because I fat fingered it. Give ourselves a little more real estate to do work with. Do a bit of wire cleanup. And now let's pull off the ratio pin and get a remap node. Let's move this stuff down a bit. Now, all we really want to do is remap the 0 to 1, basically to 1 to 0. Since the largest control will be first in the chain and the smallest control will be last, all we need to do is hook the end scale to the min and start scale to the min and the end scale to the max. Now those values will affect the opposite ends of the range. Cool. The last step of our controller scale logic is to have this actually affect the scale of the controls. So let's pull off the scale pin, grab a multiply node, and simply multiply the X and Y by the remap value. We'll do a touch of organization, and then plug that result into the scale of the control. Do a teeny bit more organization, and boom. We now have control over the control scales at the start and end of the chain. Pretty cool. Okay, so we have a set of controls for our spine now, but we need controls for the other parts of the shark too. So let's copy this function that generates controls for us and start having it populate the rest of the rig controls. Let's start with the head and work back. So grab your head bone, make it an array, and hook it into the bones array. And let's connect the exec pin. Now at this point, you'll notice that despite your scale values, your head control just won't show up. And I kind of did this on purpose to show we can make this function even more flexible. Our very cool and handy logic to control our control chain scale is great for multiple controls, but bad for individual controls. The reason being that since the ratio distributes a value from 0 to 1 down the chain, it effectively assigns a 0 value to a single bone because, and I'm assuming here, this is actually a multiplier under the hood and is applying both the 0 and 1 multiplier to the scale. And having a 0 value in a multiplier will always result in a 0, making our head control have a 0 scale. So what we can do is make sure our scale taper logic is only applied to arrays with more than one bone. All we need to do is grab the number of bones in the array and ask if that number is greater than 1. From there, if that is true, then we apply the taper math. If it's false, then we just use the basic unaffected scale values. And as you know, always be organizing, obviously. Now, if we compile, our head control appears. Neat. Now, there's one other thing I forgot to do here, and you'll see it if you try to change the control shape from the function. Nothing happens. And that's because I'm a big dummy. Just a guy trying to do cool things while also being a big dummy. If we go back into our function, we'll see that I never connected our shape name pins. Boom. Now we can really control our control shapes, and there's really no stopping us now. Let's go back and adjust our spine control shapes to something less obnoxious. Much better. Let's also separate the head control a bit more from the spine controls by changing its color. Now, something I also personally dislike is big values in rigs. So the scale of these controls being in the hundreds is something I personally find painful and tortures me in ways that I cannot explain. So let's burn it with fire. Let's dive back into the function and just add an initial 100 multiplier to the control scale. Your controls will likely adjust in dramatic fashion, but do not worry, balance in the universe has been restored. I organize. I compile. And now we can use sane, friendly numbers for all of our controls. But I forgot one more thing, which was apply the base multiplier to both sides of the taper condition. So this new multiplier is not applying to the control chains. So that's an easy fix. There we go. Okay, nice. From here, I'll time-lapse the rest of this because it's pretty straightforward. Any parts of the character you want to be able to affect separately, you'll want to create a function for. Grab the bone or bone chain, hook that into your bones array, and then just control settings accordingly. Now we have all of our base controls. Well, most of them. And at the moment, they don't have any relation to the other controls we've created. And we can change that a couple of ways. The first way I'll show you is probably the simplest, but is more manual and ultimately not the method we will use in the final version of the rig. The only part we will use is the creation of the root and body controls, so feel free to fast forward or stick around if you're curious. The simplest method to rebuild the hierarchy is with the switch parent node. All this does is allow you to choose a child control, bone, or whatever, and assign a parent to it. That's it. So all you need to do is follow your bone hierarchy and create the same structure with your controls. So if we do that, we will immediately notice we have not created a root control. So that will be the first thing we do. Let's make some room at the beginning of the construction event and spawn a transform control for the root bone. Let's give it a little art direction by making it a circle. We'll make sure it's yellow because that's what I'm feeling right now. And let's definitely scale it up so we can see it. Thank God it's not in the hundreds. Cool. Next, we need a control that will affect the head and spine together. This will be a key part of the rig later on. Again, it needs some art direction, so let's give it a unique shape so we can identify it more easily. I'm going to go with a rounded square since most of our other controls are circles. Adjust the rotation so it follows the shape of the shark and scale the control down to something more reasonable. And lastly, I hate how these controls are overlapping, so let's move it forward so it sits in between the head and spine controls just right. There we go. Let's also change the color of the head control now that we have the body control spawned. Again, so that we have a bit more contrast between the rig parts. Let's just make it blue, and we'll do the same for the jaw. Cool. Now that I think of it, let's do the same thing for the fins. That way our main controls are all yellow, and our other sections won't blend in too much and be hard to find. Now that we actually have all the controls created, we can now get to rebuilding the hierarchy. This is the section you can skip over if you want to get straight to the method we'll use in the final version of the rig. But here, again, all we need to do is follow the skeleton's parent-child relationships. So to start off, we'll make the child the body control and the parent the root control. Compile, and you should be able to see the rounded square body control rotate when you move or rotate the root control. Nice. The rest here is pretty straightforward, like I said. Since we know the body control will control the head and the spine, we'll want to make a switch parent node for both the head and the spine and set their parents to the body control. Compile. And both of those controls should move with the body control. You'll follow the same method for each control and the child. Cool. Now we have rebuilt the hierarchy, and when we move each part of the rig, we should see the child controls moving as we'd expect. Great work. Now the last step is to bind the skeleton to the controls in our rig. And this is where the forward solve comes into play. If we remember back to the start of this control rig section, the forward solve forwards data to bones. And here we want to forward transform data from our controls to the bones, right? So let's create a function to help us do that. Let's call it something super creative, like forward bones. Cool. Now we need two variable arrays, one for the bones we want to affect the transforms of, and one for the FK controls we want to do the actual affecting. From the bones output pin, let's grab a set transform array node. We'll hook that up to the exec pin. And from the FK controls, we want to grab a get transform array node and connect its output transform pin to the input transform pin of the set transform array. Compile and save. Next, we need to tell that function what bones and controls we want to bind together with the forward solve. So let's pull the function in, hook it up to the exec pin, compile and save for safety, and then let's grab all of our bones and turn them into an item array. Double check that they're all there and hook that up to our bones input pin. And then we'll do the same process for our controls. Now, a super important part of this step is making sure the index of each bone matches its corresponding control index. And we can see here that index 1 of the bones array is spine 1, but index 1 of the control array is body control. If we left this as is, spine 1 would snap to the body control position and you'd get some pretty odd results. And your shark's spine will likely break. And we definitely don't want that. So we need to remove the body control from the array by opening up the array on the right side here and just deleting it from the dropdown. Cool. Now if we check, we should see that the indexes all match between the two arrays. Now let's connect the FK controls to the function, compile, do a little organizing, save it, and then let's move some controls around and see what we get. Hell yeah, it lives. Next, we can make sure we are able to utilize the backward solve by doing the opposite of what we just did for the forward solve. We basically want to have the bones transforms affect the control transforms. So send the data backward. So let's duplicate our forward bones function and call it backward bones. All we need to do here is swap what the bones and FK controls are affecting. So we want to get the bones transforms and set the controls transforms with that data. And there you go. organize and done. Now just drag that function in, hook it up to the backwards solve, get references to our bones and controls, hook them up, and we've got the ability to author animations, bake them out, and then take those baked animations and apply them back onto the rig controls to further edit and iterate on them, which is pretty cool. But again, we can do better. As I mentioned earlier, there is a better method to rebuild the control hierarchy. The best part about it is that it's way simpler and helps us keep our rig graph clean by being able to remove all these switch parent nodes, which makes my brain happy. Let's start off by disconnecting all of those switch parent nodes. Compile, and we should now see that the controls no longer affect each other. Let's dive back into our create controls function and add a new single rig element key input variable called parent. Let's also create a single local rig element key variable called our parent to store that parent data in. As always, let's give ourselves some room to work. And let's set our parent local variable and hook the parent input variable up to it. Always be organizing. Now let's change the parent of our spawn control from the bone in the bones array to the new parent variable. Then from there, we want to make sure that each control that spawned becomes the parent of each following control that spawned by setting our parent variable again after the spawn control node. Hook that up and then compile. Lastly, we want to make sure we can grab specific controls from our function so that we can use them as parents of controls spawned from our other functions in the rig. So let's add a new output variable called fkcontrols. Make it a, you guessed it, rig element array, and then hook it up to the controls variable. Now we can set the parent of our spawned controls and grab data from those controls array. Let's start rebuilding the hierarchy. First, let's make the root control the parent of the body control. Cool. Now the root control affects the body control again. Now to make things a bit cleaner and limit the amount of spaghetti in the graph, I want to make the body control a variable. So all we need to do is create a variable and call it body control. Drag that into the graph, set it, and then hook the spawned body control up to the new variable. Now we can reference it anywhere we want. So let's make it the parent of the spine chain and make sure it works. Sweet. We are on our way. Let's go ahead and delete all of those unused nodes now that we are sure this new method is working. Let's give ourselves a little bit of more room to work. And since we know we need the body control to affect the spine and the head bones, let's also make the body control the parent of the head control. Now let's set the parent of the jaw. And what we can do is drag off of fkcontrol output pin and find the element we are looking for. In this case, the head, since the jaw is attached to the head. And we'll also grab an at node because we want to grab an element at a specific index. From there, we can hook the element from the at to the parent, setting the head control as the parent of the jaw control. Cool. Now we can see that the body control still affects the spine and head together, and now the head controls the jaw, which is great. Now you'll probably notice that the fins are still not being affected by any of the other controls. So let's fix that. First, let's move some of these functions around and make things a bit easier. And since we know the fins are children of spine 2, let's move this up to where we are constructing the spine. Now let's follow the same process and find the spine 2 control. Get its index and set the fin control's parent to that element. Compile, and there we go. We've rebuilt the hierarchy and removed a bunch of unneeded nodes. We now have our basic animation rig we can use to animate all kinds of things. You can definitely expand upon this based on your character design. Maybe it has antenna or more fins or whatever that you can easily add to this rig with all the elements we've created. The world is your oyster. Now let's get to the really cool stuff, the procedural secondary motion stuff. So let's head down to the forward solve, and from our bones array, Let's grab a for each loop and hook that up to the exec pin. Next, we can drag off of that and grab a set transform node that will convert to a set translation node. This will allow us to affect the translation of each bone in the array. Now from the element, let's drag off and get the transform of each bone. What we basically want is to get the bone's current transform, affect it, and then reset the bone's transform. So from the get transform, let's get a spring interpolation node. This is where the magic happens. Let's make sure to hook the translation to the target of the spring interp, and then connect the result of that to the translation value of the set translation node. Last, let's make sure to set the element we want to affect by connecting our item to the element. Compile that, and let's see what we got. Nice, now we have some cool secondary drag happening to the tail. Let's dial in some values to smooth this out a bit so there's no overshoot and it feels more like water is creating resistance against the shark. That's feeling a bit better, but you'll notice that this effect is only applying to the translation and not the rotation of the bones of the tail. The tail stays at its initial rotation, but the bones are moving side to side. This is an easy fix. From the get transform, let's drag off the rotation output pin and create another spring interp node. And this time, let's make it a quaternion to affect the bone rotation. From the result, we can drag off and set transform again, and it will convert that node to a set rotation node. Connect that to the set translation, set the element in the item input pin, compile, and let's check it out. So satisfying. Let's dial in a few of the values to make it feel a bit more like we're underwater, and we're nearly there. One thing you'll notice is, in this case, the jaw is also dragging behind the motion. So all we need to do is remove it from the array of bones we are affecting. So from here, we can use the same method to get specific elements from an array we use to rebuild the control hierarchy. So we get a find node, and this time we will look for a bone and make it the jaw. Then all we need to do is connect that to the index, bing, bang, boom, we no longer have a slack-jawed fool for a shark. And here we are. We have our basic animation rig with procedural secondary motion with controls that we can use to make specific poses and animations to use in-game. Next, we want to create a second layer to this rig that we will use for in-game purposes. Cool. We are officially entering the final stretch. So we have a simple control rig we can use to author animations, and we now need to create a second layer to this rig that we can use for runtime use. All in all, this is a super straightforward process and really just uses a lot of the same components we've already built. So our first step is to make sure we can switch between our two rig modes, let's call them, the animation mode and the in-game mode. And the simplest way to do that is with a branch. Let's give ourselves some extra room here. And from the import skeleton node, let's get a branch node. This is where we can create a second lane for our in-game mode. Now let's create a new variable, and let's just call it animation mode and make sure it's a Boolean. This really just needs to be an on-off switch. Let's drag that in, set it, and place it in front of our branch. Let's also drag another reference to it in again, but this time we'll get it and just plug that into the condition of our branch. Now let's do the same down here for the forward solve so our shark looks less exploded. And now we have the ability to choose one set of logic if the animation mode is true and another set of logic if it's false. You can see here when I turn it to false, all of our controls go away because we're not running the construction logic from the true pin. So, and you can probably guess what's next, off of the false pin of the branch, we will start to build our in-game rig. First thing we need to do is make sure we create a root control. Now, we could have done this before the branch so that we are always generating a root control regardless of the condition, but I kind of want to affect this differently than the root in the animation rig. So let's drag off the false pin and first create a sequence node. Then from there, spawn a control node. This guarantees that we generate a root control first, then run our logic. We'll then name it, set it to a transform node, and then ultimately just turn it off. This control really won't have much of a purpose in this branch of the rig. It's really just here for organization. So next, what we'll want to do is create a new function we will call createLookAtRig. That'll automatically open up, but let's first go back out to the main graph and drag this new createLookAtRig function in and just hook that up to the B pin of the sequence. I want to do this so we can actually visualize what we build inside the function. Let's also make sure the animation mode bool is false so we are running the in-game logic. Let's jump back into the function, and from here, let's create a control stack at item node. We could just spawn a control like we've been doing, but like I said, there are 1,000 ways to do anything in control rig, so I'd figured I'd show you another way to generate controls. This is really just a more robust spawn control node that allows you to spawn a control at an item. You can see here we can also assign a parent, have access to all of our shape parameters, and we can even have it spawn nulls around this generated control, which is super handy when building more complex rigs. There's a ton of other great parameters to this stack node that I encourage you to explore while you're building your rig, and hopefully you'll start to understand how it's entirely possible to generate whole rigs through functions that use these types of nodes. Now let's spawn this new control at spine 1, set its parent to the root control, and name it forward with the suffix _control. Cool. We now have a forward control at the location of the spine 01 bone, and it's parented to the root _control. It did its job perfectly. Let's just quickly art direct this guy a bit, make it an arrow, turn it kind of a yellow, scale it up to something that's visible. We'll rotate it to point it forward, and then we'll move it forward so we can get it out in front of the shark. And then after a bit of pondering, I've decided to make it a seafoam green. Cool. We now have an arrow. Let's do this again. Grab another control stack at item node, and this time let's generate this control at the head bone and have its parent also be the root control. This one's name will be lookat with a suffix of _control. Next, let's art direct. Make it a solid sphere that is yellow. Cool. Now here, we want to move this control around in a different way than through the transforms and the shape settings. The reason being that this is essentially just a visual offset. We want to move the initial position of this control a bit further in front of the shark, since this is going to be the target of the lookat functionality. So off the exec, let's get a set transform node. Set it to transform, and then make sure it's affecting its initial position. Now let's move this a reasonable distance in front of the shark, and then just scale the control up a touch. Sweet. Now we have all the controls we need for our in-game rig. Next, we need to have these controls affect our skeleton. And as we know, we do that in our forward solve. So let's jump down, and now we need to create a new function to drive our lookat controls. Let's call it forward lookat. We'll quickly hop out and hook this up so we can see what's happening as we build this new function. Hop back in. Now in here, our job is super duper simple. Just get the arrow to aim at the ball. That's it. And by God, we're in luck because there's a node exactly for that. And it's called the aim constraint node. Let's grab one of those and set the child to be the forward control arrow and the parent to be the lookat control yellow ball. One other very important element to set here is the target space. This determines what space your aim constraint is evaluated in. For example, if we leave this blank, it's by default evaluating in world space. And since we are using Z as the up axis in the node, then the world Z will be the axis we rotate around, as you can see here. But if we rotate the root control, the aim controls don't rotate because they are essentially bound to the world space Z up. But if we set this to the root control, we are now essentially telling the node that we want that up axis to be the Z axis of the root control. So now if we rotate the root control, we see that the aim constraint rotates with it because it's using the z-axis local to the root control as the axis to rotate around. And that's what we want. This will allow us to let the shark bank left and right if we want that, and still maintain the ability to look at the target control. Really just gives us more flexibility if we need it. Cool. Let's hop out and let's finish this thing, y'all. Home stretch. Now, we need to have these look at controls affect our skeleton. We've done this before, but we're going to do it slightly differently this time because this is just super simple. What we need is for the forward control to affect the root control. That way, wherever it points, the root bone will follow. And all we need for that is to grab a parent constraint. So let's make the root bone the child and the forward control the parent. Compile and save. And now if we move our look at controls, the root bone aims in its direction because it is now constrained to the look at control. And that's super cool. We can point our character any direction we want with a single control. Now let's take this to the finish line and just copy our secondary motion logic from up here, paste it down here, and boom baby, our shark truly lives. You have now created a control rig that has two modes that you can use both for authoring animations and for use in game. Congratulations. Proud of you, buddy. Now let's do a few final things to get the rig totally finished. This look at control can now be turned into a variable that we can reference from outside this rig. All we need to do is create a variable, make it a vector, and make sure it's instance editable. Now let's drag this in, and off of that, get a set transform node. Let's set the item to the look at control. Now, one more super important thing is that anytime you want to affect a value inside of a control rig from an external source, we have to convert that value from world to rig space. Rig space is really just local space for the control rig. This will make sure that any values in your world or gameplay space are being converted accurately to the control rig and affecting the controls based on its movement in the world. So off that look at position variable, let's get a from world and then plug that into the value. Nice. Now we have a variable that we'll be able to reference from our anim blueprint that can read a value from a blueprint. Okay, we're pretty much there. The finishing touches here will be to author a very quick and dirty swim cycle, hook it up to our anim blueprint, and reference our control rig. I'll time lapse through this because it's pretty straightforward. Just drag your control rig into the scene and get to animating. Now, before we export, one thing we need to do is make sure we can turn off our secondary motion in our control rig so that when we export it, that secondary motion is not baked in. So to do that, all we need to do is go back into our control rig, go to where we have our procedural secondary motion, and right before the for each loop, we'll put a branch that we can use to turn on and off that secondary motion. Right-click and export your animation. There you go. Animation authored. Let's pull that into our swim idle state we made at the very beginning and hook it up. sure it loops. Next, let's go back into our control rig and reactivate both our in-game rig and our secondary motion. Then let's go back out to the anim graph, right-click, and grab a control rig node. Hit compile, and then over here at the bottom of the node, we can reference our control rig. Find the one we need, and there you go. You have a very tiny shark. Now, this is because the parent constraint inside the control rig is affecting scale. So all we need to do is go back into the control rig, open up the filters, and then uncheck all 3 dimensions in the scale. And there you go. Now he's normal again. Nice. Your control rig is now affecting your animation at runtime, and we can affect the direction and movement of the character on top of that animation. It's all just so cool. I love it. Now, as far as the external influence on the look at location variable, I'm not going to go in and implement an entire enemy for this video, maybe in the future, but I can run you through the general idea. Here we can expose the variable we want to affect by ticking this box. Now, if we had our enemy BP set up with, say, a point that is controlled by its targeting component, or even just the actor's forward vector, we could use that point's location, add the location of whatever you wanted the character to look at, maybe you, and then update the lookout location variable in the ABP with that vector value. All we need to do is cast that enemy BP, grab that point, grab its translation, and pipe that into the variable. That's pretty much it. Oh, and one last thing that is super important. In your enemy BP, make sure to set the rotation fields on your skeletal mesh to use absolute rotation. Otherwise, the influence from the world on your control rig will be reduced, I imagine due to inaccurate conversion from world to rig space. Whew. Well, I hope this was enjoyable. This became a much larger walkthrough than I had anticipated, but again, I wanted to be as clear and thorough as I could. I hope this was what you were hoping to see and learn. I will continue to create more videos like these on more advanced rig topics in the future, so please stay tuned. Also, this is YouTube, so please, if this was cool, like, subscribe, and spread the word. I'd love to keep doing this and grow a bigger and bigger community of badass tech artists. I'm even considering releasing project files on Patreon in the future if folks would like that. Let me know in the comments below how you liked this and what else you'd like me to cover in the future. Thanks a ton for watching, and until next time, farewell.